Okay, in problem set 52, we're going to introduce negative exponents. But before we do that, let's review what you know so far. We've talked about the exponent rules, the definition of exponents. When you have a base to a power, the power tells you how many times the base is multiplying itself, right? In particular, if you have a base to the first power, you just get itself back. So, for example, 3 to the 1 equals 3. Don't get that confused with a base to the 0 power. A base to the 0 power is always 1. So what would 3 to the 0 be? 1. By far the most useful rule you've learned so far says that if you're multiplying and the bases are the same, you keep the base the same and add the exponents. It does not apply if the bases are different or if you're adding these, right? It's only if you're multiplying and the bases are the same. Okay, well, we're going to introduce a new rule with negative exponents. Your teacher will talk about why this rule works, but let's just talk about what it's saying here. It says if you have a base to a negative exponent, it means the reciprocal. It means 1 over the base to the positive exponent. For that matter, you can think of this as saying something kind of similar. If you have a negative exponent on the denominator, you could move it to the numerator and make it a positive exponent. See what's going on? Negative exponent on the top, move it to the bottom, make it positive, the denominator. Negative exponent on the denominator, move it to the numerator, make it positive. I like to think of these two rules together. Whenever you move an exponent across the division sign, this is the division bar, you change the sign of the exponent, you see? Cross the line, change the sign. When you move an exponent across the division bar, you change the sign of the exponent. That's what it's saying. So for example, we're going to simplify these problems, and part of simplifying means we don't leave our answers with negative exponents. Okay? So what would 4 to the negative 2 be from the definition we just talked about? If you have a base to a negative exponent, it means the reciprocal. So it would be 1 over 4 to the positive 2. See, when you move it down to the bottom, you change the sign. Cross the line, change the sign. So the answer is 1 over 16. Now don't get that confused with this. Which would you rather have? This many $1 million or this many $1 million? Well, I'll tell you what, I'd rather have this many $1 million because negative 4 to the 2 means negative 1 times 4 to the 2, which is negative 16. So you see, the placement of the negative sign affects it greatly. If the negative sign is in the exponent, it means the reciprocal. If the negative sign is in front of the number, it means you're multiplying by negative 1. So it's really important you see the difference between those two. All right, let's do some more here. So what does our rule say? What if you have a negative exponent on the denominator? Well, again, cross the line, change the sign, says negative exponent of the denominator, you could move it to the numerator and make it positive. So this would just be 4 to the 2, which is 16. What would this be? What would 4 to the negative of negative 2 be? Well, last time I checked, the negative of negative 2 is just 2, right? So it's just 4 to the 2, which is 16. I guess another way to think it would be, if you have a negative 2, that moves it down to the denominator, but if you have a negative of that moves it back to the numerator. So think of those two negative signs as you're moving down to the bottom and then back up to the top. You could think of it that way too. Either way, you end up with 16. Let's keep on going. We'll work a couple more, then I'll give you some to practice. Look at the difference between these two. Oh, this is so important. The key to understanding the difference between 5 and 6 is understanding what is the base. What is being raised to the negative 4 power? On number 5, since there's no parentheses, the negative is not part of the base. Negative of 3 to the negative 4th with no parentheses means negative 1 times 3 to the negative 4th. So the negative sign is not part of the base. The only thing that moves down is the 3. You see how the negative 1 stays on top? So your answer is negative 1 over 3 times 3 times 3 times 3, which is negative 1 over 81. Now on the second one, though, since you have parentheses, the whole base moves down to the bottom. You see you have 1 over parentheses negative 3 to the 4th. Furthermore, when you multiply negative 3 times negative 3 times negative 3 times negative 3, you get positive 81. So make sure you understand the difference between these two problems. Let's see if you got that down. Try these two. Hit the pause button. hit the pause button, see if you can work these two problems here. Okay, on the first one, the base is negative 5y, so the whole thing moves down to the bottom. It's 1 over parentheses negative 5y squared, which is 1 over negative 5y times negative 5y. On the bottom, you should have gotten 25y squared, so it's 1 over 25y squared. Now on the number 8, the base is just y, so negative 5 stays on top, and just the y squared moves down. Y to the negative 2 moves down and becomes y squared. This is your answer. Okay, so it is kind of subtle. Let's keep on going. I'll give you another chance in just a minute. Now remember, this is not simplified if you have any negative exponents. So when you get rid of the negative exponents, move them down to the denominator, you have to understand what is the base of this exponent negative 3. The answer is the base is just x. Negative 2 stays on top, y squared stays on top, x to the negative 3 moves down and becomes x to the positive 3. How about this one? This one actually has nothing to do with negative exponents at all. You have to be ready for that. This is coming from what you just learned in the previous problem set. When you multiply, you can multiply the coefficients together and get negative 15. And since you're multiplying and the bases are the same, you can add the exponents. M to the third times m to the 1 is m to the 4th. Sneaky, huh? You got to be ready for that. Look at this one, number 11. In this one, you got a negative exponent on the bottom, so you'd move this whole thing up to the top, make it a positive exponent, so you get 2 times parentheses 3y squared, and then that'd be 2 times 3y. Your final answer would be 18y squared. How about this one? Look at number 12. What's the answer to that? The answer is you can't do anything. And it's because you're adding and the exponents are different. This has exponent 3, this has exponent 1. These are not like terms. Okay? You can't add the exponents because you're adding, not multiplying. And you can't add them together because these are not like terms. This would have to be an m to the third in order to add these together. So they're just not like terms, nothing you can do. Alright, let me give you a couple minutes. Go ahead, hit the pause button. We'll go over these two in just a minute. Okay, on this first one, it's not simplified because you have a negative exponent. So the only thing you would do here is you would move the exponent to the top and call it x squared. Notice the 3's up on top along with the x squared, so 3x squared, and the 2y stays on the bottom. The last one, what you would do, since there's parentheses around here, you'd move the whole thing down to the bottom, right? Now you wouldn't leave your answer like this though. You would you'd move the negative up to the top at the end, wouldn't you? Okay, I guess that's it for now. We'll see you next time. Bye-bye.